Hello, Physics Nation. My name is Nate Larmond. This is not a drill. We are actually going to attempt online learning. Go to the district website, go to Schoology. Let's see, choose your course. These are all my courses. I teach AP Physics and Engineering, a bunch of sections of physical science. Let's do physical science first. This is first block. Let's see here. This is all the old stuff. My bosses are encouraging me to take late work, so take the old quizzes. They're all still open. Upload any unfinished labs you have, and do the presentations. I'm actually taking presentations down here. So this is the new way you're going to demonstrate your understanding in front of your classmates. It's the same idea. You can read, like with a screen capture software like I'm doing now. This is Screencastify. There are lots of different products that'll help you record what's on your screen. Or you can, do an experiment if you want to do some measurements. I'm sure you've got some tools available to you. Hopefully, you can measure distance and time. The presentations are exactly the same sort of format that we did in the classroom. Just contribute to the dialogue and demonstrate your understanding in some way. Upload it right here, and then, show me an artifact of your show for the old presentation grades. Anyway, let's check out this new assignment. Let's see, we're going to measure G. Acceleration due to gravity is a function of drop height. Okay, so this is how the math teachers say it. They always say y is a function of x. That is, x is the input or the independent variable. We're going to play with drop height. We're going to drop something from like half a meter, 1 meter, 1.5 meters, 2 meters, and see how that affects acceleration. If it does affect acceleration, is there a linear relationship, an exponential relationship, an inverse relationship? We've got a whole family of functions that can describe relationships between two variables. And that's what we're going to go searching for. We're going to try to examine the infinite beauty of the mathematical universe with some experimental data. So these are all sort of learning tools. This is our online textbook, OpenStax. If you're feeling that, you can read a little bit. These are super cool videos. Veritasium, this dude attacks some common misconceptions about falling objects. The third hyperlink is Apollo 15, where they drop a hammer and a falcon feather on the surface of the moon. There's obviously no atmosphere on the surface of the moon. Something really cool happens, and then a BBC series with Brian Cox drops a bowling ball and some feathers in the world's biggest vacuum chamber provided by NASA. So this is a pretty cool video too. So these are all hooks. This is like the phenomenon sort of segments to get you excited about this experiment. I'm excited about this experiment. I'm going to ask you to predict and examine how the drop height of a projectile affects its acceleration. So again, this is how the math teachers say it. Acceleration is a function of drop height, and this is just the straight up question. How does drop height affect a projectile's acceleration? We've made a lot of tables, drawn a lot of graphs, written a lot of sample calculations, and hopefully you can write a coherent paragraph. Usually we have a little dialogue before we take the quiz, but you got to write a paragraph because we're not probably going to have any dialogue. So what's up? We're going to drop a tennis ball from rest repeatedly for a wide variety of heights. Notice I don't tell you how many times to drop the projectile. I don't tell you what heights. I don't tell you what range of heights. That's all up to you. But there are 3 simple calculations you're going to do. You're going to find the average velocity by dividing the drop height by the fall time. Then you're going to find the final velocity by doubling the average velocity. And then finally, you find this acceleration, the rate of change of motion, by doing the final velocity minus the initial velocity divided by the drop time. Here are some analysis questions. Here are the important equations. It's actually a different problem, but average velocity equals distance over time, and then the final velocity equals double the average velocity. And finally, here's the definition of acceleration. So, good luck.